Hello everyone. In the previous session, we have learned about the different data structures pertinent to pandas. One of which is data frames. The other one here is going to be the series data structure. We also have learned that panel is again another data structure which is three-dimensional in nature. However, in the most recent versions of pandas, panel is deprecated. In place of panel, you can consider multi-index data frame where there are multiple levels that are associated with multi-dimensional or multi-index data frames, considering each data frame to be stacked on top of each other. So every two-dimensional data frame here will be of a specific level, making it multi-dimensional or having more than two dimensions here. So level 0, level 1, and this is level index 2. Within every level index, you again can perceive row indices as well as column indices here. But we are going to do a deep dive into what data frames are and what series objects are in this session and the following sessions. So rectangular data, that is the structured data that we have discussed earlier, was the customers data, wherein we had different customers. Each customer actually represented a particular row index or a customer ID here. And there are multiple attributes or variables associated with every given customer. For whatever cell value that I'm currently encircling, that indicates the spending score attribute of this customer index 4. And whatever I'm encircling now indicates the annual income of this particular customer with customer ID 9. So this is how you need to interpret the structured data or tabular data. Data frames are the primary data structures which are actually two-dimensional in nature, which comprises of these ordered collection of rows and columns that we have been discussing about. So we both have rows as well as columns. So rows indicated by row indices, columns indicated by column indices or column names as such. So here each column that we are having can be of different data types. So however, when you have discussed about NumPy arrays, we understood that all the values within the NumPy array are to be of same data type. But here that's not the case. You can have multiple columns here. Each column might denote a different data type altogether. If you closely observe, the data type of gender is completely different from age when compared with other variables or other attributes like profession as well as work experience. So gender here is categorical in nature. Age here is numeric in nature. So this is integer and this is character type or object type to be more precise. So we can check the D types of every individual columns as well for a particular data frame. Now we are going to completely represent this structured data in the form of a data frame. So how do we go about creating the data frame is what we are going to understand now. So create a data frame. That's the first step that we are going to deal with. So for that, I am going to define a new dictionary called customer dictionary. So as we can clearly understand, a dictionary will have key value pairs. The first key being customer ID. So customer ID, I'm providing 6 different values for it, ranging from 0 to 5, 6 being excluded for the reasons that you are aware of. The range object is always going to generate starting from this particular value of 0 till 6, but 6 is getting excluded here. I'm wrapping this in the form of a list. And then the subsequent key value pairs are going to be gender. Provide a list of possible values for gender for all the 6 observations that I'm planning to include. So the first customer would receive a gender of male, second one would receive a gender of female, third one female again, fourth being male, fifth being male, and sixth being male altogether. Okay. The subsequent key value pair here is going to be age. I'm going to make use of np.random.randint in order to generate values for all of these 6 customers within a range of 18 to 55. The age value can range in between 18 to 55, and the size or the number of values that I'm planning to generate here is going to be 6. So now I am creating this particular dictionary called customer dict. Okay, let me rerun this code. And now we understand that customer dict is created. So it will be created. We are going to make use of this class specific to pandas called as data frame. I'm providing this particular customer dictionary that I have created in the previous step as one of the arguments, or I can say that I'm passing this to this particular class. And now I'm calling this particular data frame as or object as custdf. So what I have created here is nothing but a data frame. It's a data frame object. To be more clear on this, you can print the type of this object that we have just created. It clearly states that it's an object pertinent to this class called data frame. So since it's an object, now you will be gaining access to multiple of its attributes as well as methods here. So provide dir, just print all the contents of this dir. So as to understand what are the different attributes and methods that you can gain access to by making use of this particular new method, sorry, by making use of this particular new object that you have created. So customer df is a new data frame object that we have created, using which we can gain access to most of these attributes or all of these attributes as well as methods here. So we clearly understand age, customer ID and gender, which are the first few attributes that are present here, are nothing but the columns pertinent to that particular data frame. So you can reference the data pertinent to all of these columns by making use of these attributes. So you simply can consider cust underscore df dot age. That's going to generate the values pertinent to these age column. Whatever values that you had for every single key that we have defined within the dictionary are nothing but the column values here. If you observe, all the 6 different values that we have provided for gender here now translated to 6 different values pertinent to the gender column for different customer IDs that we are having within the data. Same is the case with age. So all the data that we have provided here corresponds to the data pertinent to age column within the data frame. So that's how you need to interpret this. And now I'm just trying to reference this age column alone by using this dot notation. So I'm just referencing this particular attribute of this object called custdf. So as to understand what are its different values for different customer IDs here. For different row indices, what are the different values? For example, 22 is the age pertinent to row index 3. 48 is the age pertinent to row index 5. Okay. You can also reference the same column by using subscript notation here. So within subscript notation, you are providing the column name in single quotation or double quotation. That's also going to reference to the same value here. Okay. The type of this particular column that we have tried to reference is going to be series. So this is an object pertinent to series class. Referencing any given column is going to generate a series for us. So we can consider data frame to be collection of different series objects. So this here itself is a series. Customer ID is a series. Gender here is a series. Age here is a series when looked at it individually. If you observe, when I tried to reference this particular column data, it actually resulted in a series object altogether. Okay, I believe now you have understood the difference between series as well as data frame and how you reference every individual column that we have defined by first creating a dictionary here, by first creating a customer dictionary. So this is one way of defining or creating a data frame. So there are other methods of creating data frame, probably by using numpy array. So let me create a numpy array, a two-dimensional numpy array first by using np.array and np.random.randint and provide a range of values. So within this range, please generate 48 different values here. Just trying to reshape it to 6 by 8, 6 different rows and 8 different columns. Now array2d will hold all the data that now I have defined. You can very well check the shape of this. The shape of this is going to help us understand the number of rows and number of columns. So there are 6 rows and 8 columns that are represented for this particular array because that's what I have planned to reshape the complete data into. Okay. Now we can make use of this in order to create a data frame out of it. So please provide this arr underscore 2d within the parentheses so as to create this new data frame called df. And we can also very well check the shape of this newly created data frame, which matches with what the array 2d shape is. However, we have not explicitly provided the column names as such, and hence implicit indexing is considered. So if we have not provided any columns explicitly, then obviously it's going to consider the index values for these different columns. If you actually try to get the columns of this particular data frame by using this attribute called dot columns, it's going to produce these column indices that are assigned to this particular data frame. And if you want to reference the row indices, you reference it with the help of dot index, it's going to produce the different row indices that are part of this particular data frame. Let's say, for instance, if I would want to update the columns here, I want to update the columns of this particular newly created data frame, then I can simply go about providing columns is equal to provide the column names here within a list. Let me write a simple list comprehension here. I for I in the different values pertinent to this particular range object. Okay, there are 6 columns and hence, so there are in total about 8 different columns. So let me provide 0, 8 within the range object. So this is going to assign x0, x1, x2, x3 and so on till x7 as my column names now. Now all the column names are updated from its indices to the respective column names that I have tried to define here. So this is how you update column names. You also can update the row indices as well by just simply considering this df.index and then simply can explicitly provide the different indexes here. So there are in total about 6 different observations that you are observing currently, and hence I'm providing six different values for all of these row indices that I'm planning to add. Now all the row indexes are now updated. All the column indices are also updated to proper column names. And now I can reference any of these rows by using row indices. How do I select specific rows from it, or how do I select specific columns from it, is what we are thoroughly going to discuss in all of our upcoming sessions. But how do you select a specific column is already what we have looked at. So df within subscript notation, I can reference any given column so as to get the resultant data pertinent to that particular column. If you observe, 77, 23, 98, 75, 30 and 57 are nothing but the values pertinent to this column called x underscore 2. And the corresponding row indices are also displayed. Okay. So this is how you need to interpret the row indices as well as column indices. Also change the existing column names to user defined column names. Also change the row indices to a different set of row indices that we have explicitly defined now. Okay. And there is a particular large data. So this is a scenario that we are going to discuss now in order to understand the different methods and its properties pertinent to a data frame object. Let's say that there are 1 million records within your data. So in the raw data that's provided to you to solve a specific business problem, you are provided with 1 million records and you would want to quickly inspect the data. You cannot go about printing the complete 1 million records in this notebook file. So you can make use of this method called head and provide the number of observations within the parentheses that you would want to inspect the data for. So I want to inspect only the first 3 records and hence I have provided a value of 3 within the parentheses. So this is going to return the header of this particular data frame for me to inspect how the data would look like. Just like we have head, you can change the value here. So if I'm changing it to 4, top 4 records will now be printed out. Just like we have head, we also have a method called tail in order to display the bottom 2 records. Since I have provided the value as 2 within the parenthesis, it's going to display the bottom 2 records of this particular data frame. So likewise, you can explore various methods that are associated with this object. Also try to infer its functionality. I'm just running through the key methods that one can leverage in order to get some details about the existing data frame. So .info here is going to help me understand about the different columns pertinent to that particular data frame. Like the number of observations, there are 6 different observations. All of them are not null. 6 non-null observations that you are currently observing. Respective D types, all the variables or all the columns here that are represented in this particular data frame are of type int64. So this is what we can perceive from info. And if we have already looked at this particular describe method, the describe method is going to help us understand what are the different numeric variables that are available within your data. For all the numeric columns or variables, you're now going to get these statistics. So count is the number of observations pertinent to every single column. Mean value of x0, mean value of x1, mean value of x2, so on and so forth. We have standard deviation computed for every column, minimum value for x0, maximum value for x0, maximum value for x1 and so on. 25th percentile, 50th percentile, 75th percentile values as well. So this is giving us a quick insight into the different numeric variables or numeric columns that are available within your data frame. So you can leverage these methods or functions in order to inspect the data, try and understand the data, also look at drawing certain insights from it. So essentially we have looked at 2 different means in which you can create a data frame. The primary method that we have incorporated is to create a dictionary and use the dictionary for creating a resultant data frame. We have tried to reference every individual column by using subscript notation as well as dot notation. We have looked at the type of the data frame, we have understood that series object is nothing but any column that we are trying to reference in a given data frame. And later we looked at method 2, which is by using numpy arrays, we are essentially going to create a new data frame, explicitly provided the column names here by writing a list comprehension. Also explicitly defined the row indices here, reference specific columns, explored various methods or functions here, which can help us quickly inspect the data, like inspecting the header of the data, tail of the data for specific number of observations, information about the different columns, how many non-nulls are there, how many number of observations are there, what are the D types of it. So df.describe helped us identify all the numeric variables, provide these quick summary statistics for us to perceive certain insights from it. Okay. So that's pretty much all I wanted to discuss with you in this session. In the next session, we are going to explore more on the series objects. So how do we create a series object? How are series and data frame both are related to each other? We'll also explore the different methods and attributes that are in turn associated with series object in the next session. So that's all in this particular session. And thanks for watching.